So hello friends, welcome to all of you. So in this tutorial series, we are going to learn about the snappyHexMesh tool of the OpenFOAM. Okay. So here also I'm going to start from the basic of the snappyHexMesh. Then I will go to the advanced level. Then finally we are going to learn about the some coding aspect of the this utility of the OpenFOAM. So let's just know what is the definition of the snappyHexMesh. Then we will going to see some tutorial cases. So speaking about the snappyHexMesh state, so it can be used to produce the 3D meshes and which consist of the hexadra or the split hexadra kind of meshes it will contain. And generally the snappyHexMesh is being used from the STL kind of format of the surface geometry. Okay. So this is the basic idea about the snappyhex that you take some STL format of the surface geometry and then you using that STL format of the surface geometry, you create some complex kind of meshing. So at this level, it is appropriate to say this snappy hex mesh as a mesh sculpture rather than saying it is a mesh generator. Now you might be a little bit confused at what is this sentence. So let me tell you why I'm saying this statement. Snappy hex mesh always asks for the background mesh. So without background mesh, you cannot use the snappy hex mesh. Then what happens? You provide snappy hex mesh as background mesh, and you also provide a STL file or an complex geometry. Then what the snappy hex mesh does? It just casts out the whatever the STL file or whatever the complex image or STL surface you have provided. That it will cast out or cast in into the background meshes. That is why it is better to say snappyHex mesh as a mesh sculpture rather than say a mesh generator. If still you are confused here, don't worry. When you will see some examples, then these points will be more clear to you. So let's just see some steps of the snappyHex mesh. So this is the overall flowchart diagram that I think you can find this diagram on the OpenFOAM Doxygen also. So you can just go there and you can just look into diagram. So these are the major four steps that usually we follow in the while you are going to use the snappyHex mesh. So first you need to have a background mesh. Then you also have some geometry. So using this background mesh and this geometry, you do the castellation, snapping, and the adding layers. So before going into the depth of these steps, so I think it will be better that we should see one examples here. Okay, so one at least one example I should explain here. Then we will going to see each step in the more detail. Anyway, before going to the example, just let me show you the what I want. What are the algorithm that we follow in the snappyHex mesh? So this is the steps that you need to follow here. So first we need to have the background or base mesh. Generally this background mesh is being created using the block mesh. Then we also specify a geometry and then this geometry is being casted into the this background mesh. That is why this step is called as the castellated mesh because we are casting out the whatever the geometry we are providing into the background mesh. That is why this step is called as the castellated mesh. Finally, there will be snapping. So snapping is generally the we try to snap out the boundary of the given surface and more discussion we will do on these three steps, that is castellation, snapping, and addition of layer. And then finally the mesh quality is the most important requirement that we are going to discuss here. So these steps we are going to discuss in the each step in the more details, but first let's see one tutorial and then from that tutorial it will be more clear that what are these steps. So let's go to the Ubuntu terminal. So let me just start with typing the OpenFOAM 6. And now the OpenFOAM 6 environment has been created. Now we can go to the directly we can go to the foam tutorial. Okay. So if I type here snappyHexMesh, you can see that there are many examples available here that is related to the snappyHexMesh script. Okay, so we can take some examples from anywhere. So let me start with this example, that is the incompressible simple form motorbike. So let me just create OpenFOAM 6 environment, and we are going to copy this motorbike test case here. Okay, so this will be test case that we are going to copy here. So first we can type cp minus r and foam tutorials, and then incompressible, and then I think after incompressible this is the simple form and motorbike. Simple form and motorbike. Okay, so this folder, it is we it this folder we want to copy where the location is the present file location, that is the symbol to copy for the present location. Okay, so when we type here, and we can see that now there is a one folder, that is the motorbike, and you can also see here. Okay, so let me explain you the file structure for the snappyHexMesh. So of course there will be zero folder, that is everything related to the initial bounding condition. Then there will be a constant folder. So here you have try surface. Okay, and the snappyHexMesh dict folder will be present in the system folder. Okay, so this is the folder that is required if you want to use the snappyHexMesh dict tool of the OpenFOAM. Now here if you open the, let me open in the Genie editor. So if I open here, so you can see here that this three steps is important here, that is the castellation, snapping and add layers. We are going to explain these three steps in more depth. So for now just I'm giving you that three steps is required here. And if you want to just use castellation, you can just turn on true this castellation step. If you want to just use the snapping, you can just you can add either false or true here. So this is the criteria to turn on these things or turn off these things. Now here you can find that there is a one try surface, that is the motorbike.obj. So this try surface object is required to castell out this object from the given background mesh. And of course there will be one searchable box, and this box will be also uh, created in the background mesh. Okay, so this is the two method that you can use create a geometry. Either you can specify a .stl or .obj file, or there are some specific geometry automatically defined in the src folders that you can use like that. Like if this searchable box is already defined in the src folder, and if you type this keyword searchable box, it will automatically create a searchable box with the minimum point this and maximum point this. So some searchable box kind of things geometry has been already defined in the OpenFOAM, and I will also give you a table about that what are the different geometry has been already defined in the OpenFOAM. But for now this geometry is being going to be created in the background mesh. Now how OpenFOAM find the background mesh? So when you open the system folder, you will find there is a block mesh dict. So this will be for the background mesh. So let me just start with creating the mesh. So when I go to the CT motorbike, okay. So if I open the motorbikes, currently we will not found any folder name as the polymesh. So remember in the meshing class, meshing tutorial, I told you that OpenFOAM only knows about the polymesh. So every mesh information is stored in the polymesh folder in the constant. So in constant folder there should be one polymesh if mesh has been generated. So currently you can see here that there is no any folder name as the polymesh. So what I can do, I can just start with the block mesh. So mesh has been created. Now you can see here that there is a one folder name as the polymesh. This is the boundary, faces, neighbor, owner and points. Okay, so how these things are related to each other. For that purpose, you can refer to my previous tutorial. I have already created one tutorial on the mesh structure in the OpenFOAM. There you can see that how these things are related to each other. Okay, now if I open the this background mesh, so you will find that there is a just a 3D block you can find here. Okay, this is just a 3D block. Nothing is special about it. So these things is going to act as a background mesh for your object or for your searchable box. snappyHexMesh, this .motor.obj should be present in the this try surface folder here. Okay, so this folder should contain whatever the STL file or whatever the obj surface you want to cast out into the background mesh. This should be present here or written means available here. But here you are not seeing any motor.obj because in all run there is one command that cp foam tutorials. So this command we can run it manually, and this is going to copy this motor.obj.gj into the this constant and try surface folder. Okay, constant this try surface folder, this is going to copy here, so we can run this command here. Okay, and now you can see here that this motor.obj.gz folder is present here. Now this is the going to act as the geometry for this snappyHexMesh. Okay, let me extract this here. Okay, so this .gz folder is now written as the .obj. So let me again open the background mesh here. So this is the background mesh, and if I open this motorbike.obj, that can also be in the form of the STL file, and let me just reduce the opacity. Okay, so now you can see here that this is the motorbike that is going to be cast out from the this given background mesh. Okay, so this is the complex geometry background. This motorbike.obj is the complex geometry, and using this background mesh, it is going to be cast into the this background mesh. That is why I call that we should call it as a mesh sculpture rather than saying it as a mesh generator. Okay, so let's run this snappyHexMesh command here, and then we will see how it is going to generate the mesh or create the mesh. So before running the snappyHexMesh command, let me just run the surface features command. Okay, so what is this command? We will learn about this when I will explain about the every step of the snappyHexMesh. But before that, let's just run this snappyHexMesh and then see how this mesh has been, this .obj has been cast out on the given background mesh. So it will take some time. So here you can see that the snappyHexMesh simulation has been completed, and it takes around 321 seconds. Okay, so this we are running on a single processor, that is why it is taking so much time. You can run this snappyHexMesh simulation on a parallel. So if I open this all run command, you can see that this decompose has been done, and the parallel command is used to run it in a parallel. Okay, so if I open this folder, you can see that this 3 folder has been created here. Okay, so when we run just like a snappyhex command, then the all the whatever the modification is going to performed on this poly mesh of this block mesh, that is background mesh, it is going to be performed in the 3 steps, that is 1, 2 and 3. So let me open this in the paraFOAM, then you will see that how these things is working. This was our background mesh. Okay, so this is the background mesh. Let me just now when I go to the first case, then you can see here that little bit about the snapping has been done here. So now I think this motorcycle can be seen in the mesh here. Okay, so you can see here that this snapping has been done here for the given motorcycle. This some adding layers has been also added, and how these things are working that we will discuss a little bit later. But this is the simple example where you can see that how this snapping mesh has been being performed. Okay, so this complete snappyHexMesh things has been created in 3 folder. Now if you want to run the simulation, it is better that you copy this complete cells from this folder to this constant folder. Okay, because this is the just a background, this is just a background mesh. Okay, so there is two things: either you can start running this snappyHexMesh with override command. So if you type this snappyHexMesh override, then it is going to override this constant polymesh folder. So it is going to override this constant polymesh folder. Otherwise, if you run only such snappyHexMesh, then whatever the steps is being performed, that is being created as a different time step folders. Okay, and here you will find a constant folder. So this is how the snappyHexMesh dict works. I will give us just a simple example. Now let's explore the different parameters of the snappy. So these are the different steps that we have followed, and what I told till here only, that is the background mesh or base mesh. So there is two important things that you should keep in mind while creating the background mesh, that it should be hex dominant mesh, and the aspect ratio of a given mesh or a cell should be around 1. Okay, so these two things you should keep in mind while creating the background mesh. So generally it is very good to use the block mesh dict of the block mesh dict utility of the OpenFOAM, because that is automatically it is going to create a hex dominant mesh. So that is why generally whatever the tutorial you follow using snappyHexMesh dict, there the utility block mesh dict is generally used to create a background mesh, but it is not mandatory, it is not compulsory. You can use any kind of mesh tools to create the background mesh, but these tools you need to follow that it should be hex dominant, and second it is going to be it should maintain the aspect ratio equal to 1. And why this should be hex dominant and why the aspect ratio should be 1, that we will see while we do some more advanced tutorial cases. So if we see a structure of this snappyHexMesh, these three things you will find here. Okay, so first there is a castellated mesh, snappy mesh, and add layers. Okay, so these three important things that you are going to find in a snappyHexMesh dict tool. So depending upon your problem, if you want to just use the castellated mesh, I don't want to use snapping or adding layers command, then you can just turn on this true, and these two things is going to be false. Okay, so these things, what is the castellated, what is the snappy, and what is add layers, I will give you one tutorial examples. Then after that these three boolean operations, that is true false, then there is a geometry dictionary. So it is whatever the geometry you want to cast it on a given background mesh, this information should be provided in this geometry sub dictionary of this geometry sub dictionary of the snappyHexMesh dictionary. Then this is related to castellated mesh control. So that is something related to that you want to cascade out a given object or given STL file from a background mesh. Okay, and this is something that is the snapping controls. So means the features that is you are casting from a given background mesh, the feature that is being casted, so how much accurate you want to casted it out at the edges, okay, or at a feature edges, you can say that things should be provided in the snap controls. Okay, and if you want to add layers at a boundary of a this snap this STL file or a STL surface or object surface, this information should be given in this add layers controls. Now what should be quality of your mesh while using the snappyHexMesh stick tools? Those quality settings, mesh quality settings should be provided in this subdictionary. Now I think little bit you are comfortable with the snappyHexMesh. Still, if you have a mind like this, so don't worry, we are going to dig into more deeper about the snappyHexMesh dict concept of the OpenFOAM. Okay, so but some concept I think you might have clear till now that if you want to find the utilities of the snappyHexMesh dict, you can just type this command in a given terminal after creating the OpenFOAM background, and it is going to give you all the utilities that is related to snappyHexMesh. Similarly, you can find the tutorials. Okay. Now, if you say about the location of the snappyHexMesh dict, this should be generally present in the system folder. But again, it is not mandatory. Okay, why it is not mandatory? That I will tell you that you can put this dictionary in any of the folders, but generally it is advisable that this folder should be present in the system folder. And apart from this dictionary location of the snappyHexMesh dict, the input file, that is the STL and .obj file, this should be present in a constant folder, and that is the image, that is something that is going to control the feature edges, as I told you, that should be present in the constant folder, and there should be one mesh quality control folder. So this all are related to snappyHexMesh dict. Okay, so this is the main dictionary file, and these things are going to complement the snappyHexMesh dict. Okay, so these are the input files that is going to required here. Okay, now let's discuss about geometry. Okay, so let's see that what are the different possibility of the creating a geometry in the OpenFOAM or in a for a snappyHexMesh dict. So speaking of geometry sub dictionary of the snappyHexMesh, so as I mentioned that either you can specify the .stl or .obj file. So before starting the simulation, you should check that whether this .stl or .obj file is present in the constant drive surface folder is not or not. Okay, so these two things you should check, and then for that STL surface, you should specify the block mesh script folder to create a background mesh using the block mesh script. Okay, so this para view, opening it in a para view will give you idea that what should be boundary, what should be bounding box for the your meshing simulation. Okay, so let me show you other examples if you want to create the geometry. So either this should be STL file or .obj file. This STL file or .obj file you can either create using any CAD/CAM of a CAD/CAM modular. So if you want to use a open source software, there is a one software that is the FreeCAD. So using this FreeCAD software, you can create that STL or .obj files. Okay, there are some other predefined objects is available in the OpenFOAM. So like if you want to specify some predefined kind of geometry, so this command, that is the searchable sphere, searchable box or searchable cylinders, these things you can use. So I can give you one table. So this is the table. So if you want to create a shape like a box, then this searchable box command you can use. where you need to specify the minimum and maximum bounding box of the this searchable box. For cylinder, you can use the command searchable cylinder. So here you have to modify the midpoint of the cylinder of the top and the bottom, and there should be one radius of this cylinder. You can also specify searchable disk. So here in this searchable disk you should specify the origin, and then there should be one normal of the that disk and one radius should be there. Okay, so difference between the searchable cylinder and searchable disk is that you don't need to specify the height of this searchable disk. Okay, searchable plane you can specify using the point and normal. Plate you can specify, and I think if you refer to the snappyHexMesh tutorial, you can find this all kind of the shapes in one of the tutorials. So just refer to the tutorial cases in the OpenFOAM. You will find examples of these different geometry shapes there. I am not going to cover all these things, but just because the parameters already specified here, and some shapes format you can write here. So either one or two examples I can give you, and then you can easily relate between the examples I am going to present and these examples. Okay, so I am here going to talk about how to create a background mesh. This is the first step, and then we are going to also specify geometry. Okay, so using the block mesh we are going to create the background mesh, and I will also create a STL file. So to create a STL file we are going to use the para view here. So this task 2 we are going to perform, and we should going to keep mind that it should block mesh should contain the hex mesh, and the aspect ratio should be 1 near the, at least near the STL file. This should be aspect ratio should be 1, and this is another important parameter that I have not mentioned, that there should be at least one cell intersection with the STL file. So if you are creating, so what I mean to say that, so here you can see that the STL file is intersecting their large number of the cells. Okay, so you can see the 1 2 3 4 5 6 7 and so on. So this is the number of cells are being means intersected by this this STL file geometry that we are showing here. Suppose you created some mesh like here only within these cells, and your cell size is very larger, and you are specifying some STL file within this cell, then it is not going to detect by the mesh you are specifying, and this snappyHexMesh script is not going to work on those STL or any geometry. Okay, so it should be keep mind that at least one cell should intersect the STL surface. So these things we are going to adopt while we are going to develop a tutorial case, and first part we will focus on the castellation. Okay, so with these two things we are going to focus here. First we are going to create a STL file using the para view, and then for that STL file we are going to create a background mesh, and then we will do the castration, and we will see some parameters in the castellation. Then after that we will go to snap, and then of course at last we are going to do adding layers. Okay,